Ever wonder how AI can churn out essays, code, or even jokes in the blink of an eye? It's not magic, it's smart engineering. Today, we're diving into a breakthrough called OmniDraft, a technique that's making AI faster, more flexible, and way more efficient. Let's unpack it. Here's the challenge. Large language models, LLMs like GPT or Llama, are incredible, but they're slow. Think of them as marathon runners, super strong, but they take time to build momentum. To speed things up, researchers use speculative decoding, a process where a draft model guesses the next words and a target model checks if it's right. It's like a writer drafting a story, then an editor polishing it. This cuts processing time in half, but there's a catch. Traditional methods only work if the draft and target models speak the same language. If they're from different families, like one using snowflake and another using flake, it's a mess. That's where OmniDraft shines. Here's the trick: an n-gram cache. Imagine a bilingual dictionary that translates tokens between models. If the draft model says snow, the cache maps it to flake in the target model's vocabulary. It's like having a real-time translator for AI, making cross-model collaboration seamless. But it doesn't stop there. OmniDraft keeps getting better. When the target model corrects the draft, the system adapts, like a student learning from a teacher's feedback. This online knowledge distillation ensures the draft model evolves, even as user needs change. And here's the cherry on top: adaptive drafting. The draft model isn't just guessing, it's thinking. If it's confident, it proposes more tokens. If not, it slows down. It's like a chef tasting as they go, adjusting the recipe on the fly. The results? A small model like Llama 68M can now work with giants like Llama 38B or QN2-7B. And the speed? Up to 1.5 to 2 times faster on tasks like math, coding, and writing. Why does this matter? For devices like your phone or smartwatch, where power and memory are limited, OmniDraft makes AI faster and more efficient. It's the key to personalized, real-time AI without draining your battery. So next time you see AI generate text, remember, tools like OmniDraft are making it all possible. Thanks for watching. Hit subscribe for more. Let's break down the mechanics. The draft model acts as a first pass, proposing tokens. Think of them as words or phrases. The target model functions as the editor, validating these guesses. In joint training, the draft model gets instant feedback, adjusting in real time. But here's the clever twist. Interleaved training stores some draft responses in a buffer, like putting your draft aside for a while. Later, the system uses those stored ideas to refine its acceptance predictions, kind of like revising with a fresh perspective. Now let's talk about n-gram caches. These are sequences of tokens, like for loops in coding or deep learning in tech talks. In structured fields, certain n-grams recur so often they become shortcuts. The system learns to prioritize them, speeding up processing without losing quality. It's like knowing which phrases your teacher loves, so you use them strategically. Check out this table. They show how some tokens map directly between models, while others need translations via the cache. Even if a token isn't a perfect match, the system keeps refining it through cross-vocabulary distillation, aligning the draft model's vocabulary with the target, S. It's like learning a new language by gradually borrowing words from a dictionary. And the results? Over time, the draft model gets better at guessing what the target model will accept. Watch Figure 6. The acceptance ratio climbs steadily. This isn't random luck, it's the draft model learning the target's style, like a student finally nailing their teacher's preferred way of writing. The takeaway: these techniques make AI smarter, faster, and more precise. Cool, right? Let me know your thoughts below.